Leave the dais to Professor Utta.
Thank you very much, Professor Mishra. Good evening, everyone. So we'll start the next session. It's my pleasure to invite I'm supposed to come up here and talk. It's my pleasure to invite Janakiram Reddy, right? You are going to be the making the presentation, I think. Yeah. So this is a joint paper by Mr. Rajkumar, Janaki Ram Reddy, and Basant Kumar Jana, and will be presented by Janaki Ram Reddy. He is working in Coastal and Environmental Engineering Division of NIOT, involved in mode bay, is it? Mode boy observation data, collections, quality control, also involved in maintenance of high frequency radar installed in the Indian coast. Janak, please. I think you got your.
Good afternoon, everyone. Now I am going to present on wave characteristics observed by HF radar sites along the east coast of India. Others Rajkumar, Janikaram Reddy and Vasant Kumar Jana. We are working in National Institute of Ocean Technology under Coastal and Environmental Engineering Division. Like if you are seeing the first icon, like Indian Coastal Ocean Radar Network. Actually, these are specialized radars installed along the Indian coast. If you are seeing 5 pair of one minute pointer pointer okay. If you are seeing this along the Indian coast, we are seeing like in Orissa, one pair of radar stations in Puri and Gopalpur. Next in Andhra Pradesh, like Yanam and Machilipatnam, Tamil Nadu, Kadalur and Kalpakam, and in Gujarat, and in Andaman Nicobar Islands like Port Blair and Hud Bay. These systems are it will measure both offshore, like 200 kilometers offshore, like an electromagnetic wave, like 5 megahertz system will be transmitted and reflected back based on the Bragg scattering and the Doppler shift. This will measure like cover about 30,000 square kilometers to 40,000 kilometers offshore. This data is very useful not only for currents and the waves. Apart from that, the data can be interpreted like for oceanographic studies, like based on the current direction and all we can do in the modeling studies, because like this is spatial grid. It will goes up to 200 kilometers spacing at every 6 kilometer. This data is more fine resolution than the satellite data. And like climate research, and we can monitor the during the cyclone also very efficiently, like cyclone during the cyclone tracking we can get the hmax, like significant wave height and maximum wave height in along the cyclone path, along the cyclone track. Apart from that, oil spill, pollution monitoring, search and rescue, buoy tracking and marine safety. And these systems are also useful for tracking the vessels also. I will show you the detailed explanation in the next slide. Like this is the typical setup of the site actually. Like if you are seeing, like there are, if you are seeing like two antennas are there. One is the transmitter antenna, other one is the receiver antenna. Transmitter antenna will emit the electromagnetic wave continuously in the 360 degrees. We can see this is the 7 meter height. This will be installed near the coast. These 5 megahertz systems are installed in the land only. It can be maximum space up to 250 meters from the water length to travel the electromagnetic wave. And apart from that, one data collection system like central processing system will be there internally. We'll have both the stages like RX stages and TX stages, and every 1 hour data it will be transmitted to the central sites NIOT and INQOIS. If you are seeing, this is the principle, actually the basic principle. At a radio wave will be emitted from the transmitter antenna. It will be, what to say, the receiver, the received echo signal will be collected by the receiver antenna. Like there will be like two major activities like backscattering and the Doppler shift. If you are seeing like suppose if the electromagnetic wave, that is 5 megahertz system which is emitted, wavelength will be around 67 meters, that the reflected energy will be half of the wavelength will be collected like lambda by 2 every time. Suppose if there is no waves in the disturbance in the surface, waves in the ocean surface, then it will be like the Doppler shift will be same. What is the energy we are giving, the same energy will be reflected. If there is a difference, if it is measuring like Doppler shift, if we are seeing bottom like advancing current and receding, there is a change in the peak actually. It is moving away in the red color. If you are seeing that there is some disturbance in the ocean, so that disturbance, that based on the Doppler shift, will measure the Doppler spectra for every 18 minutes. We will collect it, every Doppler spectra at 1024 seconds. This Doppler spectra will be processed as a, what is a radials, and we will that I will show you in the next. This will be, this is the Doppler spectra. This Doppler spectra will have two things actually, like one is first order peak and the second is second order peaks actually. First order peaks are majorly used for the understanding that there is an echo, like there is any disturbance in sea. If there is no disturbance, the color will be normal, like there is no breaks in the ocean. So based on this Doppler spectra, we will process it and we will measure the currents and waves. Waves are measured with the second order peaks, whereas currents are primary peaks. You can see here loop 1, loop 2 monopole. This will be like for finding the direction with what the incoming wave is coming in the receiver antenna. Receiver antenna will have three, like will have loop 1, loop 2, loop 3. It will collect the voltages actually to find out the from where exactly the wave it is coming, from which direction. Like if it is moving away from the target, moving away towards the antenna, it will be positive Doppler. If it is moving away, then it will be negative. Like how we will estimate wave estimation from the HF radar. Like I have shown you before the spectra, like the second order peaks will be used for estimating this thing. We will be using a technique called fitting with a model of ocean wave and integral inversion. So in this we will be using integral inversion method, which provides the detailed information. Like we will be fitting a model, a basic model background, so that from that we will derive the parameters like wave height, period and direction. There are some limitations based on the radar, each radar, because based on the frequency, these are 5 megahertz system has limitations like it will measure more than 1.3 wave height only. It will not measure the less than 1.3. These systems are very useful when the high wind wave activity should be there, or high wave activity should be there in the ocean. Like if you are seeing, like we will assume like a radial cell path. Each radar, what it is assuming, like from the coast, if you are assuming, we will assume like a each circular path. Along the circular path, it will be same actually. And this is what 6 kilometer resolution we will get the data. This will be useful during cyclone. Why? Because it measures up to half of the wavelength, half of the like 200 kilometers current will measure. Secondary peaks will be up to 100 kilometers actually. We can measure up to 100 kilometers. And here it will be like deep water condition will be considered actually. Like coming to the results actually, the two systems where we installed in Gopalpur, Puri, if you are seeing during the cyclone Titli, we are compared with the Wave Rider Boy of Gopalpur. It measures like good match, like Same wavelength, like 9.25 was measured from our HF radar, whereas the Gopalpur boy measured like 9 meter at the same time.